All right, today we're going to be looking at section 2.2, definition of limits. And we first start out with the definition. Suppose f is a function for all x near a except possibly at a. If f of x is arbitrarily close to L, so L is some number on the y-axis, for all x sufficiently close but not equal to a, we write limit of f of x as x approaches a, so that x means arrow pointing to a means x gets close to a is equal to L. So I'm going to go over the highlights. You see a graph, they give you some examples. They basically are saying as you get close to some number coming from the left and the right on the x-axis, the y value is getting close to some number as you approach, tracing the graph from left and right on the y-axis. And whatever that number is representing our L. You have some other examples, and then we talk about one-sided limits. So you have a right-sided and a left-sided. So when you see the limit of f of x as x approaches a, and you see a little plus up above it, that little plus indicates we're approaching whatever that number is, a on the x-axis, and we're coming from the right side. And then you have a left-hand limit, which means limit of some function f of x as x approaches a, and you see a little negative above it. That means we're approaching it from the left, so coming from the negative side and going toward the positive. So if it approaches some number L, then we say that left or right-sided limit exists. And then you see several different examples. They show some where you have a smooth graph. You might have a hole in the graph. As long as both the left and right side of the limit approach that number, we can say that that limit exists for right now, or that the limit of the function is equal to whatever value it approaches. I don't want to say it exists, but we do have a limit. So you just see multiple examples. One thing we do is we work on plugging in different x values, so 1.9, 1.99, 1.999. So we just inch ever closer to 2 from the left and from the right. And you can see what the y values look like. Looks like they're getting bigger, close to 3 when you round. And the same thing, these are going down toward 3. So this goes over the relationship between one and two-sided limits. It says assume f is defined for all x near a except possibly at a. Then the limit of f of x as x approaches a equals L, and if and only if the limit of f of x as x approaches a from the right is equal to L, and the limit of f of x as x approaches a from the right or the left is equal to L. So that means that both the left and the right side limit have to equal the same thing for that limit to exist. If they don't, the limit does not exist. So here's an example where you have the left side of the graph is approaching, looks like a y value of 2. The right side is approaching negative 2. Those are two different values, so that limit would not exist. And then we have some trig applications, so we got to be careful with those. These are kind of like oscillating, harmonic motion, and this would not be a function, so we'd have to restrict this function so that it's a one-to-one function. So because this graph oscillates, we couldn't find the derivative. We have to have a one-to-one function, so we'd have to restrict this graph and then find the limit for that point. But other than that, we're just going to jump over to MyMathLab and then start working a few examples.